Space. It's a brilliant world that can make us feel like inconsequential specks in the vast universe of swirling planets and bursting stars. It can nourish our minds with its great diversity of phenomena to observe. But many of us remain ignorant of what happens outside of our bubble, and we miss a chance to see the greatness that lies right in front of our eyes. One of the great mysteries of space are black holes.
How are black holes formed?
Well, anything can become a black hole if it was condensed into a small enough piece of matter. For example, let's take a look at our sun during its final throes of life. Now, if our sun was about 20 times its mass, during its death, the core would plunge inward.
Gravity would use all of its force around the star.
The temperature would increase to 100 billion degrees, while atoms are shattered into electrons, protons, and neutrons, then quarks, leptons, and gluons. The death of a great star becomes the birth of a black hole. So then, what are black holes?
Black holes aren't really anything. They're just a blank spot in space where an infinitely dense whirlpool is surrounded by a boundary called the event horizon. The event horizon is the dividing line between the inside and the outside of a black hole. The matter that is affected by the black hole is channeled into streams that blow away from the hole at phenomenal velocities. These jets can extend for millions of light years and can travel straight through an entire galaxy. Essentially, black holes facilitate a recycling space process where old stars in galactic center are spun and swirled into gas that cools and combines to form new stars. Scientists discovered black holes with the new images they could observe from using X-ray and radio wave technology. This allows scientists to collect light in wavelengths that cut through the interstellar dust. The telescopes act as an X-ray that sees the interior bones of galaxies. Time is also a factor. Space-time can be thought of as an elastic sheet that bends under the weight of objects placed upon it. The more massive the object, the more space-time bends. For example, say we were on a rocket to Sagittarius A star, the black hole in the center of our galaxy. For every minute that we spend close to the event horizon, 1,000 years would pass on Earth. The black hole's gravity triumphs over time. If we were to cross the horizon, we would appear frozen at the hole's edge. It's important to understand the basics of the phenomena in space so that we can participate more in observing the wonders of our universe.